Hey students, so on this clip we're going to be going over actually three examples on how to use the special triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangles to find the missing parts of triangles that are similar to these two triangles, okay? So before we start, we're just going to do a real quick review on how to use these triangles. Remember that these triangles, we're using the similarity of these triangles to other triangles of this with these angular measures to find missing sides, okay? So the standard 45, 45, 90-degree triangle is of this nature right here. This is an isosceles triangle. These angles are congruent. This angle is 45 degrees, and this angle is 45 degrees, okay? The side measures of the 45, 45, 90 triangle is 1, 1, and root 2, okay? Alright, for the 30, 60, 90 triangle, the smallest angle is 30 degrees, and then the next angle to that is 60, and then the biggest angle is 90 degrees, okay? And then we have 1, root 3, and 2. Alright, what I needed to keep in mind when using these triangles, these are like a compass, is where the side measures are relative to each angle, okay? So opposite the 90 degrees, we have root 2. You see that? For the 45, 45, 90-degree triangle. Opposite 45, we have 1. And opposite this other 45 right here, we also have 1. Okay? Alright, in the 30, 30, 30, 60, 90 triangle, opposite the 90 degrees, we have the side measuring 2. Opposite the 30-degree angle, we have the side measuring 1. And then opposite the 60-degree angle, we have the side measuring root 3. Okay? Alright, so let's keep these orientations in mind because that's what's going to help us solve the problems. Alright? So let's go ahead and write our instructions for the examples. So find the value of the variables in the given right triangles. In the given right triangles. Okay? Alright, so the first one, number one, let's say we have a right triangle of this configuration. Draw a sketch. So let's say this right triangle looks like that, and we're it's indicated that this is 45 degrees right here. This is 45, and this is 90, and this is y, x, and 3. Okay. All right. So for 45, 45, 90 triangle, we know that this is an isosceles triangle. This is 45 degrees. So we know that this angle has to automatically become 3. Okay, so let's assume that we weren't paying attention to the fact that this is 3. We just want to follow the procedures. So we know that opposite the 45-degree angle, right here, opposite the 45-degree angle is a 2. So this will be divided by 2. I'm sorry, it's a 1. It's a 1. Because if you look up here, opposite the 45 degrees are 1s. So you put a 1 under there and put this over 1 because it's opposite the 45. And then opposite the 90 degree is root 2. Okay? So we don't know this side and we don't know this side, we know this side. So let's circle the side we know. So what we're going to do is we're going to set these two ratios equal to this ratio so that we can find the value of the variables, alright? So the first equation, let's look for x. We want to find x. So we're going to go x over 1 equals 3 over 1. So just divide by 1, you just have x equals 3. That goes your first answer. Okay? Alright, for the next one, we're going to set this side equal to 3 over 1. So we have y over root 2 equals 3 over 1. To isolate y, we multiply both sides by root 2, and root 2. And then we'll have y, these divide out to 1. We'll have y equals 3 root 2. And there goes the measure of the second side. Okay? So this side is 3 root 2 and this side is 3. Alright, let's go ahead and and take a look at question number 2. For question 2, we have the triangle of with the following configuration. It's not a 45, 45, 90 triangle. This actually is a 36, 60, 90 triangle. Let's go ahead and sketch it. Let's say the triangle looks like this. And we have, this is the right angle. This is 30. This is 60. And it's also indicated that this is A, B, and this is 2 root 2. Okay, so we need to find A and B. Now if we go to our unit, our special triangle, that we're gonna use the 30, 60, 90 triangle. Okay, that's what applies to this case. So with that in mind, opposite the 30 degrees, the shortest side is 1. So put this over 1. Opposite the 60 degree is root 3, so put this over root 3. And opposite the 90 degrees is 2, so put this over 2. Alright? I don't know this side, I don't know this side, I know this side. So I'm going to set both ratios equal to this side right here to find out the value of the variables. Okay? So we're going to go A over root 3 equals 2 root 2 over 1. This proportion helps me find A. Remember, these are just similarity ratios, okay, that I'm setting up here. Now to get A by itself, I multiply both sides by root 3, top and bottom. I mean, the left and the right side. These root 3's divide out, so I'll have A equals 2 times root 3 times root 2 is root 6, so A equals 2 root 6. Okay? Alright, so there goes the value of A. Now let's look for B. To find the B, we're going to set up the ratio B over 2 equals, this is the side that we know the ratio, so 2 root 2 over 1. To get B by itself, you multiply by 2, top and bottom. I mean left and right because we want these two to divide out. So this divides out completely. So we're going to have B equals 4 root 2. And there goes your second answer. Alright? Okay. Now, let's move on. Alright, so in the next problem we're going to look at, we have a right triangle with the following configuration. Let's go ahead and sketch it. So let's write down the number first. So for number 3, we have this right triangle. It's of this orientation, and it's indicated to us that this is 60 degrees, this is 90, okay, and this side is y, this is root 5, and this is x. Okay, so now with that in mind, what kind of triangle is this? Since we know that this is 60 and this is 90, we automatically know that this is 30. So we're going to use the 30, 60, 90 triangle. Okay, so opposite this 30 degrees is the measure on the 30, 60, 90 triangle. Opposite 30 degrees is 1, so put the 1 here. Opposite 60 degrees is root 3, so put this over root 3. And then opposite the 90 degrees is 2, so put this over 2. Okay, so this is the side that we know completely. So we're going to be setting the other sides equal to that to find out the value of the variables, okay? So to find x, we're going to set up the ratio x over 1 equals root 5 over root 3, okay? X over 1 is just x, which equals root 5 over root 3. Now to get, you do not have a square root in the denominator, so we have to rationalize the denominator. So multiply by root 3 top and bottom, and that yields x equals root 15 over 3. Okay, because root 3 times root 3 is root 9, which equals 3. Okay, now there goes the value of your x. Now to find the value of the y, we just set up another ratio. We have y over 2 equals the side that we know the measure of, root 5 over root 3. Okay, Now to get y by itself, we need to multiply by 2 on both sides. These two 2's divide out. So we have y equals 2 root 5 over 3. Over root 3. Okay? Now you can have a square root in the denominator. So what you're going to do is we need to rationalize the denominator. Okay, so root 3 top and bottom. And then that's going to give us y equals 2. You multiply the radicand here, 5 and 3, which is 15. It's still under the square root because 15 is not a perfect square. Over root 3 times root 3 is root 9, which is just basically 3. And there goes the value of your y. Okay? Alright. Well, thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel just by clicking up here. More videos can be found on madlerserve.com. Thanks again and have a wonderful day.